All right, so in this lesson we're going to be talking about multiplying matrices, and this is actually a very useful tool for solving systems of equations. So the first one we're going to look at is a pretty basic example here, and it's just a matrix that's negative 2, 4, 2, and 3, multiplied by a matrix of negative 5 and 1. So this what I do first is I just write down what the matrix is. So this is a 2 by 2 matrix because there's 2 rows and 2 columns. This one is a 2 by 1 matrix because there's 2 rows and 1 column. So what you can do right off the bat is look at these two here. If those two are the same numbers, that means that we can multiply these two matrices together. Let's take a look at a little example that is a little bit more tricky. So we're going to go 0, negative 5 multiplied by negative 2, and 1. So when you write down what these matrices are, you would write 1 by 2 and 3 by 1, because there's 1 row and 2 columns in this one, and there's 3 rows and 1 column in this one. See, these two numbers are not the same. So when we go to multiply these together, we actually can't do it. So all you would do is write undefined, and that would be it. You're done this question. Okay, you can't multiply these together. So this is actually, when you see this on a test or assignment, you're like excited because you don't have to do any more work. You can just write undefined and you're done. This one over here, we can actually do. So I'm going to erase my little example to the side here, and let's actually multiply our first example together. So every single matrix that you can multiply together, you do the same way. The first thing I do is I look at these two numbers. Okay? Those two numbers are what the resultant matrix should be. So when you multiply these two matrices together, you should end up with a 2 by 1 matrix as a result. So when we're looking at multiplying matrices together, what we do is we look at the first row and we multiply it by the first column. So to do that, we're going to draw our first bracket, and then to do that, we look at the first number and multiply it by the first number in the second matrix. So we go negative 2 times negative 5 plus, now we do the second numbers, so 4 and 1. So 4 times 1. And this, what we're doing right now, actually is called the dot product. It's where you take the first terms, multiply them together, and then add them to the second terms multiplied together. And then if there was a third term, you would add the third term multiplied together. So now that we've done this whole, or the first row and the first column of this, we're going to take a look at the second row and the first column. So let's do it. So we have 2 times negative 5 and plus 3 times 1. And there we have it. So now we just have to simplify. So we end up with 2 times negative 5, so that's 10 plus 4 times 1, 4. 2 times negative 5 is negative 10 plus 3 times 1, which is 3, which is just equal to the matrix 14 and 7, negative 7. And that's our answer. So we multiplied these matrices together successfully. All right, so let's look at another example, and we're going to do a little bit of a more difficult one than last time, and we're going to use bigger matrices. So we're going to have 1, 2, 3, 4, 5, 6 as the first matrix, and our second one, let's go 7, 8, 9, 10, 11, 12. So the first thing we do is we write down what these are. So this is a 2 by 3 matrix because it has 2 rows and 3 columns. And this is a 3 by 2 matrix because it has 3 rows and 2 columns. So we can just look at these and we can see, okay, yes, we are able to multiply these two matrices. And then we can look at these two numbers and see that our answer is going to be a 2 by 2 matrix. So let's start multiplying these together. So we look at the first row of the first matrix and we're going to multiply it by the first column of the second matrix. So let's draw our brackets here and then let's start. So it's going to be 1 times 7 plus 2 times 9 plus 3 times 11. And that's it. That's our first value for our answer in the final matrix. I mean, all we'd have to do is multiply these together and add them all up. But we actually have, we know it's going to be a 2 by 2 matrix, so we're going to have another term here, another term here, and another term here. So let's get going on the second one. So the second one is still going to be the first row of the first matrix multiplied by the second column of the second matrix. So we're going to have 1 times 8 plus 2 times 10 plus 3 times 12. And then that's it for our top row. So let's do our bottom row now. So we're going to look at our bottom row of our first matrix multiplied by the first column of the second matrix. So let's see, we have 4 times 7 plus, you can see the 4 times the 7, plus 5 times 9, plus 6 times 11, and last but not least, we use the bottom row of the first matrix and the second column of the second matrix. So we're going to have 4 times 8, see 4 times 8, plus 5 times 10, plus 6 times 12. So then we can actually just multiply, and I just put this in my calculator, is you multiply all these together and then add them all up. If you actually put it in with the brackets in your calculator, you can actually put that all in and just hit enter and it'll give you a number. The number I get is 58 for the first entry. I get 64 for the second one. I get 139 for the third one. And then for the last one, I get 154. And as you can see, this is a 2 by 2 matrix, just like we had determined right at the very start.